Okay. Hi guys. Sorry I can't be there today. But today is review, so I think you're going to be okay. But let's quickly go over composite functions. We talked about them a little bit. Can't remember if it was before or after the test. But composite functions are one function that serves as the input into the other. So in this case, f of g of x is the same as f of g of x this way. I like to write it this way because you can see that the g of x is going to be your input function. So think of it like you've got your g of x, stuff goes in, stuff comes out. This stuff that comes out then serves as the input into your f of x function. So quick example, if f of x is equal to 2x squared minus 3 and g of x, is equal to 4x, f of g of x is going to be like f of g of x, where g of x is the input. So we take my f of x function, 2x squared minus 3, and we replace the x with g of x. So this would be 2, and then my g of x function minus 3, and then you simplify. So 2 times 16x squared minus 3, or 32, sorry, x squared minus 3. Now, composition of functions is not commutative, meaning you can't switch it around. So f of g of x is not going to be the same as g of f of x. Again, if you write it this way, you can easily see what the input's going to be. Following our same procedure, now I take the g of x function for x and plug in 2x squared minus 3. And you can see what we're going to get is 8x squared minus 12. So these guys are not the same. So you can evaluate functions, meaning you can plug numbers in. So using these same two examples, give me a sec, I'm going to move them down. So given these two same examples, if we were to find f of g of 1, what this means is I'm going to find g of 1, which would be 4 times 1, or 4. So g of 1 is equal to 4. I'm going to take that 4 and plug that into my f of x function. So again, replacing the x with the 4, I get 16 times 2, or 32, minus 3, which gives me 29. So f of g of 1 is going to be equal to 29. Finding domain. Oh, no, let's do one more. You can also do a composition of a function with itself. So g of x, for example, would be where I take my g function, here. So that's 4x, and I'm going to plug 4x in. So g of x is 16x. You can also do the same thing with a value. So g of negative 1 would give me g of negative 1, which is 4 times negative 1, or negative 4. And I take that negative 4 and plug it into the g function again. So then I have g of negative 4, which gives me 4 times negative 4, or negative 16. So finding the domain of composite functions, you have to think of what's actually happening. So again, if we've got f of g of x, we start with that g of x function, and the output goes into my f of x function. So I have to evaluate first the domain of g of x. You're going to exclude anything that doesn't work. And usually that means that g of x undefines. So taking values that make the denominator 0, taking values that take the what's inside a square root less than 0, all those things that you have to exclude. But then you also have to look at what values going into f of x do we have to exclude? Now, those values that we have to exclude going into g of x are coming through g of x. You understand? So if for example, x cannot be equal to -3, what we need to know is what goes into g of x that has an output -3. I think this will be easier with actual examples. So let's use f of x equals 2x plus 1, g of x equals 1 over x minus 2. So now what we've got, if we're looking for, let's do g of f. No, let's do the other one first. So doing f of g of x. To find the domain, remember g of x goes first. So what we need to eliminate from g of x is x cannot be equal to 2. Because if x is 2 in g of x, it makes the denominator equal to 0. Then we've got to evaluate what's going into f of x. F of x has a domain of all real numbers. So it doesn't matter what comes out of g of x. So my only limitation has to be this. So the domain of f of g of x is the set of all x such that x cannot be equal to 2. If I do it the other way, g of f of x, again, this is f of x first, and x is a member of all real numbers. You don't have to limit a linear function. What goes into g of x, on the other hand, we have to limit the 2. So what we need to know is what values of f of x, of what values of x will produce an f of x equal to 2. So we take my f of x function, 2x plus 1, we figure out what makes it equal to 2. So 2x is equal to 1, and then x would be equal to 1/2. So we have to limit the domain of g of f of x to set of all x such that x cannot be equal to 1/2. So what values go into f of x that produce the thing that we can't plug into g of x? The last part of this is going backwards. You can find the components of a composite function. So let's say that f of g of x equals 1 over x plus 2. We can actually make this out of 2 components. You can see that you've got a 1 over x where the x has been replaced by x plus 2. So using these two, we can define our functions The one that's used as the input is the x plus 2. So we can see my g of x is equal to x plus 2. My f of x is equal to 1 over x, because f of g of x is equal to, remember, you're going to make your f of x function and insert your g of x function. So this gives me the 1 over x plus 2. Let's do one more example of that. So f of g of x equals, let's try, square root of 1 minus x squared. And you can see that this is a function inside a function. You've got a 1 minus x squared inside square root. So those are my two functions. I have 1 minus x squared, and then I have the square root. So the input function is your g of x. So the stuff that goes inside is g of x, and what is it going into is f of x. One more. So f of g of x equals 2x plus 1. And again, you can see that what you've got is a function inside a function. So the 2x plus 1 is inside. Absolute value of x is the one that you're plugging into. So g of x is the input. F of x is what it's getting plugged into. And we have our two component functions. You can check this. F of g of x means I'll take my f of x function, absolute value, that was an x, and we're going to plug the 2x plus 1 in, that gives me the absolute value of 2x plus 1. All right, I think that's it. Your assignment is in Google Classroom. Again, I'm so sorry, guys. I have every intention of being there tomorrow. But I don't know the sub situation either, so I'm sorry, doubly sorry. And I'll see you on Friday.